Good day, guys. How are you doing today? Today, in the previous lecture, we talked about control structure in C++. In this lecture, we go into these classes and objects. And let's look at what classes are and what objects are. Classes are the foundational concept of C++, and classes and objects are the foundational concepts of C++ paradigms. Then a class is a blueprint or a template that defines properties and actions or behaviors. The properties can be in form of states. The state does not change, but the behavior or the functions or method change. You can either refer to a behaviors to be functions. You can either represent behaviors in terms of functions and behavior or method in C++, and state can be represented in form of variables, variable our attributes. Or for instance, when you talk about a car has many doors. The state that number of four doors, so that one cannot change. But the speed of a car can change. Can also be method to create a method to calculate the speed the speed drives. Then let's move on. We talk about a class, a blueprint, where the object is a what? It's an instance of the what? An object is an instance of that class. From a class, you can have many objects. From a template of a class is like a prototype that enables us to construct that car. Anything that car needs, that make it to functions. And from that template, we can also have different kind of instances coming out from it. Now, we talk about another example of it can be a cookie cutter, which is a class. Then a cookie is an object of that class. Let's see the reason why we move beyond procedural programming languages. But like C is also procedural programming languages. So data and functions that only take procedural programming language only talks about functions for modularity and for arrangement of our code. But sometimes the code might go complex. So that is why for more modularity and for more structures, we incorporate namespaces, a template, also incorporate classes in object-oriented programming language. Then we talk about objects or the solution that the OOP provides. This is it now. For what? For modeled software around the real world conceptual entities, also bundle data attributes and behaviors method to a self-contained unit that can be used and be reused over and over again. This leads to a better co-organization and maintainability. For instance, let's see a real world scenario or university systems where imagine designing a university system, a university portal to manage the student informations. Where then we can also have some attribute we can have about the student ID, about the student CGPA. We can also have some calculate the CGPA of the student. The student CGPA can change over and over, but the student ID cannot change over time. Once the student comes in with the ID, the student remains with that ID till lifetime. Also, let's see how we can create this, model this approach now. We define a student called a class called class. This class encapsulates all student related data like the name, the information, the GPA, behavior, the enrollment, the CGPA as well. Then we can also create out a function to carry out this. Let's see how we can create a class in C++. A class is a user-defined data type that acts as a template. It's a user-defined data type that acts as a template. It defines the data members. The data members are the attributes that represent the state and the functions, the member functions, and also the functions in that class that can be invoked through the use of the object, the instance object of that class, of that same class. It does not occupy memory itself, except class does not occupy memory except for static members. We can also have some member created with what is static. You put static in front of them. So, and now let's see, this is syntax for creating a name. or a class, sorry, a class, the keyword called class, and also the name can be anything. You can change it to be anything. It can be student, it can be payments, it can be anything you want to do, depending on, can be animal or class animal, anything you wanted to do, you want to design. So then remember not to forget the semicolon at the back here. So this semicolon here can also help us to the end of the class. By default, a class is private. Unlike struct, it's public by default. Then you can also make a class to be protected. You can also make it to be public as well. But in Java and C Sharp, you can also, you don't see this, you can't see this semicolon at the end of a class. It's removed. But in C++, it's included. But all of them come from the mother, which is C. The C is the one inherited from C. Then let's move on. Let's create a student class. As you'll be used to this from our previous lectures. We used to look at what string is. We include some preprocessors, and then we include the vectors for dynamic array. Then the IO stream, input-output stream as well. Then we create a class, the same class we saw here. We give the name of students. Then this is private here. This can only be accessible. All these variables we have here can only be accessible within the class, within the scope of the class. Can you see? This is the beginning of the scope, and this is the end of the open braces and the closed braces. So that's the end of it. Then we have all the, you also see the private here? It ends here. Everything, all the data attribute here, all the state here, they represent the state, they represent the state, the attribute that cannot change. So they all represent, they are also private. Can you see? You see private here, that means you cannot access them outside of this class. So, but in public can be accessed outside of the class. Then this is the name. Here, if you come down here, there is a public constructor called class name. Class name defined. If we fail to define our own public constructor, this public constructor here, we make it public, and for us to be able to instantiate the variables here we have here. Then we can also, these are the member functions we have here. Void it means void, and enroll courses. Can you see? We can't just call this function outside just like our C. We have to create an object of this class in order for us to be able to access all the member functions here. Then let's see creating object now. An object is concrete entity created from class blueprints. So from that, I told you earlier that you can create many objects from a class, can have many objects from a class, and there are different ways of creating it. You can create it via pointer, but you also remember to delete it via you need to delete it. You can also create it in form of a Java form, but that's a form of pointer, but you remove the asterisk, you remove the pointer base from it. Then the state is the specific value of it. We've seen the state there, see the behavior as our functions. Then let's see in our main now. This is the student class that we created now. This is the object. This is now the object here. This is the class name here. Just like your normal name, it's like a data type, but it's a user-defined data type. That's a class. So we used to create a student A. We also have student B. We also have student C. You can see. So the student A here takes in the ID of the student, the alias. Can you see? You can see it here. That is the way we are able to to pass in the value of it. This is the ID. There's two ways we'll be able to pass value to this class here. If we do not create have the constructor here, except we want to make these things public, and which is not good for our code. So then you can then we pass the value there. So the value initialize, pass the value. This ID now goes to this student ID by now, and this student name also go to the student name here as well. Then we have student. This is another method of creating it here. This is this using a pointer, as I told you all the time, using student this. You also remove the new keyword from here and the asterisk. That's another way again. But if you do it this way, that means it's another student C. So we are creating an object on the here. So we are creating it for dynamic program for dynamic memory allocations. So we are creating an object on the here. Then we need to delete this one at the file end to free the resources allocated dynamically. Then student A dot enroll courses. Then what's the course? Here we have a function here. We will be able to call this enroll course member functions except through the instance and the public access file. Can you see this public here also affect the constructor here? This constructor also as affect this enroll course as well. If you want to make this one private, you can just put private full column in front of it, and you're good to go. But you'll be able to access it outside of that class. It will be private and you'll be able to access it. Then return 0. Then you can see the difference between classes and objects. A class is a blueprint or template, while an object is an instance of a class. Logically, entity defined at compile time, physical entity created at runtime. At compile time, when your code, you compile the code compilation, so this at the runtime. Then the architecture blueprint, memory, no memory allocated except for static. Memory is allocated when created. When we create an object, when we create an object here in the main, a memory is allocated. A value of memory is given to this. But whatever we create a class here, we create a class, we just declare it here. No memory is allocated except for static variable. In case you just put static in front of the variables, I'll give it something. So no memory is allocated there. Then analogy, the architecture blueprint for a house, because like this, a particular scenario, a house, and an actual house built from the blueprints. House is built. Maybe it can be a duplex, it can be a class of what? A class of house. There can be what? Is it 3 bedroom? Is it 4 bedroom? It's a duplex you want to build. So it can be an object from that class. So you now create the information you have already. Now let's see the object lifecycle. Special member functions are automatically generated by the compiler if not user defined. They control the fundamental lifecycle of an object. We have the constructor, the student constructor to pass the information. This is the student constructor here. I told you the right time. This is the constructor here. Here it starts taking public here. You can also have another constructor, but it must have the same, must have different signature. And that one can only take a single name, and that one can take. But then we're not creating the class. Depend on the constructor you instantiate, you create. This enables to work to achieve polymorphism, something happening in many forms as well. Compartment polymorphisms. So then you can also have copy operations, move operation, as again in C+11. If you need to define any of these destructor, remember, whatever we are also having something, sometimes you need to free something on the destruction. The destruction, you use the T sign. The T sign below your one keyboard, beside the one keyboard or the standard keyboard. So you have also have the this pointer here. The this pointer within a non-static member function. The key this is a pointer to the specific object instance the function was called on. Then we don't use a dot operator. We will use what? We use the arrow sign as you see here. We use an arrow sign here as you see here. That means what? This refers to what? To the member of that something use. So you want to use this, you don't use dots name. Unlike Java as well. Like Java as well. So you can also have calculator here. Then return this first. So return this and also return this. This here is referring to the what? To the instance of this class. To this class. So let's look at static members. Static members belong to the class itself, not to individual objects. Only one copy exists shared by all objects. Tracking total student enrollment. You can see scenario just tracking. Let's see now. Let's see example of static member here. We create our class. We have the what? Public static int total student declaration. Then we also have a default constructor. A default constructor is not taking argument here. We have a constructor here that's not taking any parameter. Then total student, we increment it for each new object created, right? Then we have a destructor. We have a destructor here to what? After so it should destroy the decrement of the operation every time with the program stop execution. So we also have static int get enrollment. You can also get the total student enroll by returning this value now. Total student enroll, you can easily get it and return it. Make sure it's static. It has to be static as well. Because when you are returning something static, whatever thing you are returning, the time must be the same thing. So you can also define then into student, total student. Can you see this is the way we call it? You don't create instance for class or for static class. You use the class name itself to what? To assign value to it. Use the class name, not that you're not creating a special variable. The same thing also in Java as well. You don't create I forgot it for C# already, but it's something for Java as well. Still remember, you don't use the same, you don't create an instance of a static. You don't create an instance of it. You use the class name itself to instantiate the variable and assign 0 to it. Then in our way now we have what? Student. This one is what? Students. Remember, this one is different from this. Remember, we are calling integer here. We are calling what? This variable here. So that's what we use here. It's different from this now. This is now instance now. These are instance. This is the inside of this. Remember, it's not taking parameter. It's taking nothing. That is why you don't see value in front of it here. So it's taking nothing. So then let's look at friend functions. Maybe friend function will be explained better. Maybe I'll just explain it now. Friend function, this enables us to get access to some classes. But one of the problem we have with it, and it's always discouraged, especially except in the special use cases, is that it breaks encapsulation. It breaks the rules of encapsulation. You can access any of the private members or private classes that you have. You can apply friend function to classes or to functions. It's a friend keyword create a control breach of encapsulation. It allows specific external functions or an entire external classes to access the private and protected members of the class that grant friendships. So this is useful when two classes are very tightly coupled. Sometimes this can happen. Maybe in case you have an object, maybe the government, maybe you have something like a bank account, you create a class called bank account, and the government try to want to get the user information about that account. A public function that can be created to be able to get access to your information, and they will be able to read it out. So it always break the rules of encapsulation. Let's see the warning here. Overuse of friend weakens encapsulation and can make code harder to understand and maintain. Always consider of public member function could achieve the same goal cleanly. Using a public member can achieve the same goal. Let's see a real world scenario. A financial aid office, a class function needs to calculate aid based on student GPA and family income, which are private. You can see. Now let's see the class now here called student. Calculate. Let's firstly create a forward declaration. Sometimes it's also good for function declaration, class declaration forward. You make a code to be aware that this class is declared and implemented below or somewhere. Then we create a class. Then we now implement the class here. Student, private, then family incomes. Then we create a constructor here. The constructor, this is the new way of instantiating values instead of the previous one we saw with assignment variables. The GPA here, get the value here and store it here. The increment here, family income, or the income here, family income, assign also to this value here. Get the same thing you are saying, GPA equal to G. This is the initializer way of initializing variable. And this one is also better. It will assign value before executing the block, the content in this block. Though that's starting the content now. Then let's create a friend function to calculate age now. These friend functions, it will end here, but it's taking what? A reference to the student, or to this student now. Can you see? It's taking a reference to this student. It's taking a reference to this student. Then we can have, can you see, we have the object of this student. So I want you to watch carefully. This is what we are talking about here now. We create a function that is taking the argument of the class, the reference class of this. And then let's go down. Let's see the way it was implemented. Now this non-member function can access a private data. Now we're able to access the private data of this class now. Now let's see, calculate age, constant, same thing was passing. Can you see? Constant student X. This is a constant student X. Then let's come in. We also what? You have GPA. Then you can easily what? S.GPA, of which normally you want to create instance of it. You won't be able to create it on normal basis, guys. Or you won't be able to do that. We try and implement that in our code. You see, we try calculate it. You see that you will be able to access the private variable. You will create a normal instance variable of that. But here we are able to access it. We get reference to this GPA, which they are private. But if you create an instance, separate instance of it in the main class, you will be able to get the instance variable. Also, what problem is the next one, using a class as a friend something. A course or class needs to manage its roster directly adding or removing student ID from student object private list of enrolled courses. You want to remove student ID from a student object from your courses. Let's try to do that one. Can you see? Class student private this. Sorry. Students private, you have a vector. This vector is dynamic. You can push back or can pop back. You can push back and push to it. This is dynamic array. Dynamic array enables us to pass information in dynamic array here. Courses here, we have course ID, pushback ID. Now we create a class or a function, a function called add courses into this. Course ID dot pushback, the ID we are adding to is going to put them into the array. Then we now create a what? A friend class course. Can you see? A friend class course here, courses here. So then we have a class courses here now. Class course, void enrollment. Then we now create we make this class a friend. That means we can access any private information about this student class here. Then we now create a public, void enrollment. We now have what? An instance of this in a function of X. Now we have a student now. It's course ID now. S.add course. We just add course ID. Let's see. Can you see? We're able to access the function here. Remember, this function is private. Normally, you will be able to access the private instances. But here now, with the help of these friend classes, we are able to access them. So thank you very much. But let's jump to our code. I have a snippet of code here also demonstrated. Because of time, I won't be able to. I know it's going to take us some time again. Let's see this. Then we create our what? We have what? A bank operator for instance. Now let's create bank account. Initialize. You also create a constructor. You have a private balance, right? Normally, if this is a one method now. I can say accounts dot deposit. You will see, I can see deposit, I can see withdraw, but I cannot see balance here. But through the help of this, I can also get account dot, can you see, through the help of the friend functions that we are having here. So I was able to get this private balance something. That is why we are advised you should use it really, because it breaks the risk of encapsulations in our code. So then let's see, let me compile now. Let me compile for us now. So cd p5 g plus z output. I feel this output. Let's give app. Let's give it any name. Then app.c cc. Then we run it again. Can you see our balance is this? We give 1,000 and we get what? We get 1,300. We deposit 500. Our initial deposit is 1,000 naira and $1,000, and then we get 500 in. We deposit 500. Then making 1,500. We withdraw 200. So 200. So 200 is now we get it. So that is how. If you have any question on this, please let me know. Please comment, like, share, subscribe. Thank you very much. Bye bye.